Hey guys, here are we starting the geometry part of the series. I will be covering over lines, rays, and line segments, and all about angles and some of the other basic stuff in this video. Let me start with a line segment. This here's a line segment. Wait, 1 second, I'll start with labeling on points. This here is a point geometry. It's the same point in your day-to-day life. Now, in geometry, the way people refer to this is by labeling. Let's call this point A, and let's call this point B. It's gonna be a little hard to see, but B. Now, this is 0 dimensions. If you want to get around, say if you're on point A and you want to get to point B, you have to go on a line segment. Now this line segment here would be called line segment A, B. You could also call it BA. Now, if you've gone forever, say in A, if it was true, this here would be called array. And now there's only one single name for it, B, A as array. That is because if you do this, A, B, it looks like the ray is going in this direction where it isn't actually. That's the reason why we do that name convention. Next I'll be doing I'll cover over what if you had a point here, you would call this a collinear. These are collinear because they all sit on the same line segment, or you could call it a plane. This could also be referred to as a plane, and that is honestly if it goes in every direction. This could also be referred to as a plane. Imagine if it was stretching out forever. A paper, except it would have to stretch out forever. I was just saying, you'd have to stretch out forever. Whoops. 1 second, I'll get you a darker. So it would stretch out forever. Next, we will be going over oh yeah, what are lines in geometry? Lines, let me draw a point. If this here goes on forever in x directions, this would be called a line. Let's label this. Now I'll use a different letter, C and D. To refer to this, you put this. It doesn't have to be this big, but you do that. 1 sec. Freak. There. Let me get a new board set up there. There. Now we're covering over my next concept. I need it dark. Don't want a highlighter. There, you can sort of see it. What's happening? What were we doing? Oh, freak, messed up. God, jeez, I don't want. There. Now, I'll be now going over on shapes, how to label shapes. Now, all shapes all have points at the end. Before I do that, I'll be covering over what a vertex is. This here is the vertex and angles. I'll be also an angle, if you want to measure it, usually people use a protractor. What they do is they set it on the angle, and it will say what angle it is. Well, what angle the measure is. To refer to angles, say let's call this A, B, and C. To refer to this angle, wait one sec. To refer to this angle here, and let's just give this a line of, let's say that's a D. This here would be called CBD. Not exactly, because you're gonna have to put this on top. But if you're referring, let's say we just draw a straight line and just put A and B. If you do this, A, B, what you do is you put how much, not the angle measure, otherwise you do this. AB equals to 180 degrees. Oh yeah, supplementary and complementary. This is a supplementary angle. Supplementary angles, they always add up to 180. This is a useful tool. Say when you have this. And complementary angles, on the other hand, add up to 90. So if you have this, say for you, this probably I would say would be 25 degrees. Since they add up to 90, you could subtract 25 from 90, which will give you 65. So this would be 65 degrees, assuming this is 25. It sort of does look like it. There, now you can just go down. Okay, there. To a different point. How's this way too thick? Whatever. Well, oh yeah, the quadrilaterals. So I finished talking about what I needed. Quadrilaterals. Now, this is my first question to you, based on all the basics I just showed you. Oh yeah, a line that's parallel, perpendicular, and skew. These are perpendicular lines. They intersect at this point, and all of them would form a 90 degree. Or in total 360. all triangles add up to 180 degrees. And shapes like these, here's the trick, these are made up of two triangles. So the trick is, this must add up to 360 degrees based on the logic following. And that is actually true. These must add up 360. Now, parallel lines are like these. They never intersect, and they go in the same direction. If I draw it on, there, they would never meet at a point. Never. A triangle does not do this, because it automatically meets over here. I have a quick quiz for. Well, these are not parallel because just meet. But even a slight change like this could do it. Could make it not parallel. Even a very slight change. That's how small of a change it could do. Now, what are a plane I recovered, but skew lines? Let me draw up a shape to tell you what a skew line is. I'm a skew point. Say you have point R, and you put it in the middle of all of these points, S and T. So S and T, are these skew? Is our skew and our is skew because it sits on the same plane. Now, if it doesn't, say if R was here, just call this point A. A is not skew to ST, because I didn't mention that. Otherwise, it could have been skew if it were in the middle of B and D. It could have been skewed. This also would have been skew, but then R would not be skewed to D and B. I think that will cover all the basics. See you in the